Hey everyone, I'm absolutely thrilled you're joining me for this explainer today. We are going to unpack one of the most familiar, yet honestly deeply misunderstood phenomena in our night sky. We're decoding the lunar cycle. We're going to break down the actual dynamic cosmic mechanics behind why the moon changes its appearance, taking these massive movements in our solar system and turning them into concepts you can easily grasp. So, if you've ever looked up and wondered how this giant sphere of rock seemingly changes its entire shape night after night, well, you're definitely in the right place. Okay, let's dive into this. Our roadmap for today is pretty straightforward. First, the secret of moon phases, then tracking the lunar orbit. After that, we'll hit angles of primary phases, and finally, we'll go inside the new moon. Starting with Section 1, the secret of moon phases and the illusion of perspective. So, it's incredibly common to think the moon changes shape because the Earth's shadow is somehow creeping across it, right? We've all kind of thought that at some point. But let's bust that myth right now. Listen to this crucial insight from our source material. What changes is not the amount of the moon that is illuminated, but rather how much can be seen. That right there, that's your aha moment. The changing faces of the moon are literally just an illusion created by our vantage point here on Earth. The moon doesn't generate its own light at all. It's really just a massive spherical mirror reflecting the sun. And because it's a sphere reflecting a single light source, exactly 50% of the moon is always illuminated. Always. No exceptions. Think of it like, I don't know, a flashlight shining on a basketball in a dark room. Half of that rock is soaking in blazing sunlight, and the other half is just in pitch-black darkness. The only thing that's actually shifting is our camera angle from down here on the ground. Moving on to Section 2, tracking the lunar orbit, the cosmic race. To really understand this cosmic race, we need to look at something called the Synodic Month. Basically, this is the roughly 29.5 days cycle it takes for the moon to go from one specific phase, like a new moon, all the way back to that exact same phase. And you know, for millennia, humanity has relied on this very specific, incredibly predictable rhythm. We've used it to dictate our calendars, guide agricultural harvests, and even help early ocean explorers figure out how to navigate. Now, what's really interesting about this is the ultimate cosmic plot twist. The moon's actual physical orbit, which is called a sidereal month, is only 27.3 days. So why is the phase cycle 29.5 days? Well, it's because while the moon is busy orbiting us, the Earth is simultaneously speeding along its own track around the sun. So when the moon finishes its 27.3-day lap, it actually has to travel an extra 2 days just to catch up to its starting position relative to the sun. It's a literal cosmic race. And astronomers, being astronomers, have timed this race with just breathtaking precision. The exact average Synodic month is 29.53059 days. Just to put that into perspective, that is 29 days, 12 hours, 44 minutes, and exactly 3 seconds. I mean, just let that numerical precision sink in for a second. It's wild. But actually, here's where the mechanics get even cooler. Individual cycles can actually vary from this exact average by up to 7 hours. Because you see, the moon's orbit isn't a perfect circle, it's elliptical. Plus you have this incredibly complex gravitational tug-of-war happening with the sun and other celestial bodies that's constantly slightly altering its speed. Let's hit Section 3, angles of primary phases, the geometry of the sky. Let's move to how this builds directly from our vantage point. When the moon is directly between the Earth and the sun, it's sitting at a 0-degree angle. That is our new moon. Then, as it travels a quarter of the way around to a 90-degree angle, we get a first quarter moon, where it's illuminated on exactly one side. Push that all the way to 180 degrees, with the Earth right in the middle, and boom, we have a full moon. Finally, at 270 degrees, it hits the last quarter phase, before heading right back to zero. It's just pure, elegant geometry in motion. Now obviously, the moon doesn't just snap from one phase to the next like a light switch. Between all those major milestones are the really beautiful crescent and gibbous shapes. And each of these transition periods lasts about 7.38 days, smoothly waxing up to 100% visible illumination and then waning right back down. Which brings us to a really fascinating turning point. We've tracked the math, we've looked at the geometry all the way down the waning cycle. So what actually happens when that visible illumination hits exactly 0%? That brings us to section 4, inside the new moon, the invisible phase. So, the crucial point here is that this is the exact moment in the cycle where the moon seemingly vanishes from our sky entirely. The new moon marks the absolute 0 point of the lunar cycle. Because it sits perfectly at that 0-degree angle between us and the sun, its illuminated half is facing entirely away from us. But honestly, the most mind-bending part isn't just that it's 0% visible. It's that it rises and sets almost exactly with the sun. This massive celestial body is traversing our sky during broad daylight, completely masked by the sun's glare. And on those rare occasions when the orbital alignment is perfectly flat along the ecliptic, that invisible daytime moon slides right in front of the sun, giving us a spectacular solar eclipse. But actually, scratch that. Even at 0% visible illumination, the moon isn't completely dark. And that's all thanks to a phenomenon called Earthshine. It's amazing. Sunlight hits our bright blue planet, bounces off the oceans and the clouds, travels all the way across space, and faintly illuminates the nighttime side of the moon. Our own planet acts as a cosmic mirror, casting this ghostly, beautiful glow on the otherwise completely unlit lunar surface. It really shifts how you think about our place in space, doesn't it? We've seen today that the moon never actually changes its shape. It's a relentless, perfect sphere, locked in a geometric dance, always 50% bathed in light. Which leaves me with one final thought for you to ponder tonight. If the invisible new moon is still vibrantly illuminated by the sun, just slightly out of our sight, what else in the cosmos, or even in our daily lives, is completely hidden from us by a simple trick of perspective? Keep looking up, keep asking questions, and I will see you in the next explainer.